All right, let's take a look at our practice test. We're told to solve each equation. And for the first problem, we're going to have an absolute value operation that's nested inside of another absolute value operation. So here you have the absolute value of, and then you have the absolute value of 2x minus 1, then minus 3, and this equals 12. So how are we going to solve something like this? Well, I want you to recall the rule that we talked about in the lesson. Let's say that you have the absolute value of some algebraic expression. Let's just call it u. And this is set equal to some positive number. Let's just use 12, since that's our number over here. Well, basically, this sets up as u could be equal to 12, then or u is equal to negative 12, right? In this case, it's very simple. To prove this, you could just plug in 12 here. The absolute value of 12 is 12, so you get a true statement. Or the absolute value of negative 12, if you plug that in, is also 12, so that will be true as well. So how can we use this rule on this guy here? Well, just consider this outer guy here as being set equal to 12, right? So what's inside is your u. So you would take what's inside here. Let me just highlight this in a different color. So this guy right here, we would set it equal to 12. Then we would say, or it's equal to negative 12, right? Either way, you get a true statement. If you got 12 in there, well, the absolute value of 12 would be 12. If you got negative 12 in there, well, the absolute value of negative 12 would be 12 as well, just like we saw here. Okay, let's get rid of this, and let's just set this up. So we will have the absolute value of 2x minus 1 minus 3 is equal to 12. Then I'm going to go or the absolute value of 2x minus 1 then minus 3 is equal to negative 12. Now, when you solve these types of problems, sometimes you'll get a setup where there's no solution. Okay, so you're going to see that over here on the right. I'll get to that in a moment. So for these two guys, the first thing you'd want to do is isolate the absolute value operation. So this guy right here and this guy right here. Okay, so on the left, you would just want to add 3 to both sides of the equation. This would cancel. You'd have the absolute value of 2x minus 1, and this would be equal to 12 plus 3 is 15. Let's say or. Over here, again, I'm going to isolate this guy. So we'd say the absolute value of 2x minus 1. Again, I'm just going to add 3 to both sides of the equation. Let me make this 3 a little bit better here. Let's cancel this, and we'll say it's equal to negative 12 plus 3 is negative 9. Now, before we go any further, do you see a problem with this guy on the right? Well, yeah. You have isolated your absolute value operation, and you're saying it's equal to some negative number. That is not possible. The absolute value operation will give you something that is 0 or positive only, right? So your answer cannot be negative there. So what we would do here is just say that there's no solution, right? So this is no solution, and that is just for this guy on the right. On the left, we can get a solution, right? The absolute value operation can give us positive 15. So for this one, again, you turn to your rule. We would say the absolute value of u, in this case, u is the 2x minus 1, that's equal to, let's say, 15. Well, then u is equal to 15, or u is equal to negative 15, okay? So we just have to set this up. So we would say that 2x minus 1 is equal to 15, or 2x minus 1 is equal to negative 15. So two simple equations to solve. Let's add 1 to both sides. This cancels. We'll have 2x is equal to 15 plus 1 is 16. And then I'm just going to divide both sides of the equation by 2. We'll cancel this. We'll say that x is equal to 16 divided by 2 is 8. Then over here, let's add 1 to both sides of our equation. We'll cancel this. We'll say 2x is equal to negative 15 plus 1 is going to give me negative 14. Let's divide both sides of the equation by 2. We'll cancel this. We'll say that x could also be negative 7. So those are your two solutions. X could be 8 or x could be negative 7. You can pause the video and go back to the original equation and check each one. You'll see that the left and the right sides are equal. I'll just tell you in advance, I've already verified them and they both work. All right, let's take a look at problem number 2 now. So here we have the absolute value of, and then it's the absolute value of 5x minus 7, then plus 4, and this equals 10. So just like we saw before, we're going to consider this outside guy here, and we will say that the absolute value of 5x minus 7, then plus 4 is equal to 10. Then we'll say or the absolute value of 5x minus 7, and then plus 4 is equal to negative 10. Okay, so those are the two scenarios. Now again, you want to isolate your absolute value bars in each case. So on the left, I would subtract 4 away from each side. This would cancel away. You have the absolute value of 5x minus 7 is equal to 10 minus 4 is going to give you 6. Then over here, if we subtract 4 away from each side, again, you're going to see you have a problem. So this is the absolute value of 5x minus 7 is equal to negative 10 minus 4 is negative 14. And again, when you think about it, this is isolated. So the absolute value of 5x minus 7, it's not possible for that to give you a result of negative 14, right? This over here on the right has to be 0 or some positive number. So once again, for this scenario, we'll say there's no solution over here on the right. So no solution. Now on the left, we can have the absolute value operation give us positive 6. That's okay. So we would say that, again, 5x minus 7 is equal to 6, or the 5x minus 7 would be equal to negative 6. So here, let's add 7 to both sides of the equation. This cancels. We have 5x is equal to 6 plus 7 is 13. Let's divide both sides of the equation by 5. Let's cancel this and say x is 13 over 5. Over here, let's add 7 to both sides of the equation. This will cancel. You have 5x is equal to negative 6 plus 7 is going to be positive 1. Let's divide both sides of the equation by 5. Let's cancel this. So x could also be 1/5. All right, let's take a look at problem number 3 now. So we have the absolute value of x plus 1, then plus the absolute value of 3x minus 7, and this equals 12. Now, this type of problem is extremely tedious to solve, and I got a lot of questions and comments and emails about it when I did it in the lesson, so I want to take my time on this first one, and then we can go quicker on the next ones. So the first thing is, you have to realize that the absolute value equations that we've solved up to this point, they had a particular strategy, right? So you wanted to isolate the absolute value on one side. Let's say you had the absolute value of some algebraic expression u, so this is isolated, and let's say it's equal to some positive number k. So this is a normal case. We say u is equal to k, or u is equal to the negative of k. All right, so we cannot do that here because you have two absolute value operations involved. So this does not apply here. Now, the other scenario is you have the absolute value of some algebraic expression u is equal to the absolute value of some algebraic expression w. Well, in this case, you would say u is equal to w, or u is equal to the negative of w. But again, we can't do that here because you have the two absolute value operations, but then you have this number over here that's going to stop you from setting them equal to each other. So this doesn't work either. So what can we do in this particular case? Well, we're going to turn to our rule for absolute value, something that we talked about in Algebra 1. We're going to say that the absolute value of x is equal to x if x is non-negative, so if it's greater than or equal to 0. And then the absolute value of x is equal to the negative of x if x is less than 0. Now, how can we use this simple definition to get an answer here? Well, notice that we're developing a rule for when we can drop the absolute value bars and what we need to do. In other words, if what I plug in for x here is non-negative, so if it's 0 or positive, I can just drop the absolute value bars and I get my answer. So in other words, if I had the absolute value of 0, I could drop the absolute value bars and I just get 0. If I had the absolute value of, let's say, 2, I could just drop the absolute value bars and I get 2, right? So it's nice and simple. But if I plugged in a negative here, or something that's less than 0, well, then I have to do additional work. I can't just drop the absolute value bars. So the absolute value of, let's say, negative 9 is not just negative 9. I have to put a negative out in front that's going to flip the sign. So the negative of negative 9, that's going to give me positive 9. Okay, so this is what you need to understand. You're splitting things into different cases, okay? So what I'm going to do is apply this strategy to this guy and this guy. So in other words, let me erase this. If I wanted to develop a rule for dropping the absolute value bars with this guy, we would say the absolute value of x plus 1 is simply equal to x plus 1. We'll say if x plus 1 is non-negative, so if it's greater than or equal to 0. And then we'll say the absolute value of x plus 1 is equal to the negative of x plus 1 if x plus 1 is less than 0. Okay, so this is a simple inequality to solve. We would subtract 1 away from each side. So let me actually just erase this in each case and just put this as a negative 1 on the right side of each. Okay, so if x is greater than or equal to negative 1, then basically we could just drop the absolute value bars, right? We would just have x plus 1 as our answer. You can try that by just saying, let's say we pick something like positive 2. So the absolute value of 2 plus 1 is equal to, well, it's the same thing as if I just drop the absolute value bars, right? It's 2 plus 1, which is 3. Okay, you can see our rule works. Now, the other one, let's say I had something that's less than negative 1. So let's say I pick negative 2. Well, I have negative 2 plus 1. Well, I can't just drop the absolute value bars, right? If I did, I'd have negative 2 plus 1, which is negative 1, which is not the right answer, right? You would want to say that this is the negative of this negative 2 plus 1, right? I've got to flip the sign because of the absolute value operation. So negative 2 plus 1 is negative 1, and so this would be the negative of negative 1, which is positive 1, right? And if you took the absolute value of negative 1, you know you would get positive 1. So this is going to be our rule, okay? So this is the basic setup or strategy. Now, you don't have to go through and write this each time. What you would basically do is come down to a table or a number line and just think about where it's 0, and then anything that's less than that, you want the negative of that expression, and then anything where it's 0 or positive, you want the expression, right? So you just drop the absolute value bars. So let me put an interval here from negative infinity going up to and excluding negative 1. And in this particular case, we want the negative of this quantity x plus 1. So we want the negative of this quantity x plus 1. Now I'm going to put the interval here in a moment. We have to work on that other one. But I do know that if it's negative 1 or larger, then I don't need the negative of this guy. I can just drop the absolute value bars. So it would just be x plus 1 and then x plus 1. Okay, so let's go back up and let's think about this other guy. So let's get rid of this and let's think about this other guy. So we have the absolute value of 3x minus 7 is equal to, again, I'm just going to drop the absolute value bar, so 3x minus 7. This is if, again, this expression is non-negative. So we'll say that 3x minus 7 is greater than or equal to 0. And then we'll say the absolute value of 3x minus 7 is equal to the negative of 3x minus 7. This is if, we'll say 3x minus 7 is less than 0. So for this one, you would add 7 to both sides. Let me just do this on both of these at the same time. And then you would divide both sides by 3. So basically, you would say that if x is greater than or equal to 7/3, that the absolute value of 3x minus 7 can be found by just dropping the absolute value bars, right? And then if you're less than 7/3, well, then the absolute value of 3x minus 7 can be found as the negative of this quantity 3x minus 7. So we're going to go down here, and we're going to think about the interval between negative 1 and 7/3, and then the interval that's greater than 7/3. Okay, and I'll talk about negative 1 and 7/3 in a moment. I know some of you are going to be confused as to why I didn't include it. So first off, anything that's less than 7/3, we know that we want the negative of this guy, right? So the negative of the quantity 3x minus 7. So the negative of the quantity 3x minus 7, and then the negative of the quantity 3x minus 7. And then if I'm greater than 7/3, then I just want the expression 3x minus 7. So 3x minus 7. Okay, so let me come back here and just copy this equation. So the absolute value of x plus 1, then plus the absolute value of 3x minus 7. This equals 12. Okay, so let me pause for a minute and talk about something that's probably a question that you're going to ask. I get this question a lot. So when some people set up these problems, you'll see them include negative 1 here. And the reason you would include negative 1 here is because at negative 1, this guy right here is going to be 0. Plug in a negative 1 there. Negative 1 plus 1 is 0. The absolute value of 0, again, you could just drop the absolute value bars. So you could include that there. And then the same thing over here, you could include this right here if you wanted to, okay? Because if you plug in a 7/3 there, this guy right here is 0, and the absolute value of 0, again, you could just drop the absolute value bars. So if you're doing this problem on your own and you want to include it, you can. Okay, it's up to you. This is just scratch work. So I always like to consider those guys separately. Okay, so this is just my strategy, the way that I do it. If you want to do it the other way, it's still valid. It's not going to change your answer. We're going to see in a few problems one where we actually get one of these guys as our solution. That is pretty much a special case, and I'll show you what to do when that happens. So from this point, all we would need to do is basically use our rule to set up a different equation for each interval. We would solve that equation, and then we would see, does the solution lie in the interval? If it does, we'll accept it. If it doesn't, we will reject it. Okay, so let's start with anything that's less than negative 1. So building my equation here, again, if I drop the absolute value bars, I use this rule. So the negative of this quantity x plus 1, and then plus the negative of, you might as well just write minus, the quantity 3x minus 7. Again, that's so I can drop these bars, and this equals 12. So I'm going to solve this, and if I get something that's less than negative 1, I can accept it. If it's not less than negative 1, I will reject it. So let's go down, we'll come back up. So here we have the negative of x plus 1, so it's just basically negative x and then minus 1, just multiplying each guy there by negative 1. And then here I'll do the same thing, so negative 1 times 3x is minus 3x, and then negative 1 times negative 7 is going to be plus 7. This equals 12, right? So if you struggle with that, you can always just put a negative 1 there and put plus a negative 1 there, and you're just distributing this to each in case you are confused about that. Okay, so from here, negative x minus 3x is negative 4x, and then negative 1 plus 7 is going to be positive 6, and this equals 12. We will subtract 6 away from each side of the equation. Let's cancel this. We get negative 4x is equal to 12 minus 6 is going to be 6. Divide both sides of the equation by negative 4, and we'll say that x is equal to, let me show this is canceling. You would have a negative because a positive over a negative is a negative, and 6 and 4 are each divisible by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. So you get x equals negative 3 halves. Coming back here, let me write x is equal to negative 3 halves. Is this in my interval? Yes, because I'm looking for something that's less than negative 1. This is basically negative 1.5, so it's to the left of negative 1 on the number line, right? So this is in this interval, so we would accept this solution. So I'll just put a check mark there. Now, in the next interval, this is between negative 1 and 7/3, so we're going to use our rule. So again, for this one, you could just drop the absolute value bars because this one's going to be positive in that interval. Or again, if you wanted to include negative 1 itself, then it would be non-negative. So we will just say x plus 1. Then to drop this guy, again, this guy is negative in that interval. So let's put minus this quantity 3x minus 7. And again, you can go plus negative 1 if that's a little bit easier for you. And this equals 12. Okay, so we have x plus, we have 1. Then negative 1 times 3x is minus 3x. Then negative 1 times negative 7 is plus 7, and this equals 12. Okay, so we will have x minus 3x, which is negative 2x. And then 1 plus 7 is going to be 8, and this equals 12. So here we would subtract 8 away from each side of the equation. This cancels. You have negative 2x is equal to 12 minus 8 is going to be 4. Let's divide both sides of the equation by negative 2. And we're going to cancel this and say x is equal to 4 divided by negative 2 is negative 2. So coming back, I'm just going to write x is equal to negative 2. Now, is this in its interval? No, right? Because this is between negative 1 and 7/3. Or again, if you wanted to include negative 1, you could say that's part of it, but it does not fit in this interval here. So you're going to reject this, okay? You don't want that answer. So then now I'm working with this interval between 7/3 and infinity. Or again, if you wanted to include 7/3, you could if you wanted to. It's not going to change anything. So we're going to say that we can just drop the absolute value bars because everything is going to be either non-negative if you included 7/3 or positive if you didn't. So we'll say x plus 1, then plus 3x minus 7 is equal to 12. So we'll say x plus 3x is 4x, and then 1 minus 7 is going to be negative 6, and this equals 12. Let's add 6 to both sides of the equation. This cancels. We get 4x is equal to 12 plus 6 is 18. Let's divide both sides of the equation by 4. So we're going to cancel this with this, and we'll say x is equal to, for 18 and 4, they're each divisible by 2. 18 divided by 2 is 9. 4 divided by 2 is 2. So this is x equals 9 halves. So coming back up here, I'll say x is equal to 9 halves. Now 9 halves is 4.5. And if you think about 7/3, I would say that's 2 1/3. So 4.5 is obviously greater than 2 1/3. So it fits in this interval, so you can accept this solution. So going back, let me just write this out here. You have x is equal to negative 3 halves, and then also 9 halves. So coming back here, I'll just paste the solution there. So this would be our full solution. Again, you can always pause the video and check each one of these, make sure it works in this equation. I've already verified each one of these solutions. You can even take that solution that we rejected, that negative 2, you can plug it in and see it's not going to work. All right, let's take a look at problem number 4. So we have the absolute value of 4x minus 7, then minus the absolute value of 5x plus 2, and this equals 6. So we spent a lot of time on the last example like this. So for this one, I'm going to go a lot faster. Again, the first thing I'm going to do is figure out where this is 0 and where this is 0. And then I'm going to set up intervals on my number line. So we're going to say 4x minus 7 is equal to 0. We'll add 7 to both sides. We'll cancel this away and say 4x is equal to 7. Divide both sides by 4. And we'll get x is equal to 7/4. Okay. So the other one, we're going to set 5x plus 2 equal to 0. Let's subtract 2 away from each side. We'll say 5x is equal to negative 2. Divide both sides by 5. We'll cancel this. We'll say x is equal to negative 2/5. Okay, so we have those two guys. And basically, we're going to use them to set up our intervals on our little table here. Let's paste this in here. So negative 2/5 is my leftmost value. So I'll say from negative infinity up to and excluding negative 2/5. Again, if you want to include negative 2/5, you can. You could say this is negative 2/5 here. And then you're going to exclude 7/4. So that interval there. Again, my preference is to do it this way. If you want to do it the other way, it's up to you. It will not change your answer in any way, shape, or form. Okay. Then the other one is going to be from 7/4 out to positive infinity. Again, if you want to include it, you can. Won't change your answer. I am going to exclude it. Okay, so let's look at our equation. We have the absolute value of 4x minus 7, then minus the absolute value of 5x plus 2, then this equals 6. Coming back here, again, in this interval right here, both of these guys are going to be negative. So I want the negative of this quantity 4x minus 7, and then I want the negative of this quantity 5x and then plus 2. Then for this one right here, this guy will be positive, or you could say non-negative if you included this. So I'll just have the 5x plus 2 here. And this guy is still going to be negative. So the negative of this quantity 4x minus 7. And then in this guy right here, again, if you included this, then this guy would be non-negative and the other guy would be positive. But if you exclude it like I did, they're both positive. So 4x minus 7, again, it doesn't change your answer if you include it or include it. And then you have 5x plus 2. Okay, so let's go through and set up our equations. So in the first case, they're both negative. So you want the negative of this quantity 4x minus 7. And then you have a minus. So you have to be really careful here. This is minus, and then you want the negative of this. So let me put this inside of brackets or something so I don't make a mistake. So the negative of this quantity 5x plus 2. Just be really careful if you have a negative, okay? Then this equals 6. So here I'm going to distribute this negative to each. So this is negative 4x and then plus 7. And then I'll put my minus sign out in front. And then inside of here, this would be negative 5x and then minus 2. And then to distribute this negative, this would be a plus. And then this would be a plus also. Okay, so make sure you use brackets or parentheses so you don't make a sign mistake with something like this. So then this equals 6. Okay, so negative 4x plus 5x is just x, and then 7 plus 2 is 9, so plus 9, and this equals 6. Let's subtract 9 away from each side. We'll cancel this and say that x is equal to 6 minus 9 is negative 3. So let's say x is equal to negative 3. Now, is that in this interval? Again, this is anything that's less than negative 2/5, and negative 3 would be in that interval, so we can accept this solution. So let's look at this interval here between negative 2/5 and 7/4. So we have that this guy is negative and this guy is positive. Okay, so let's take this first guy and say it's the negative of the quantity 4x minus 7, then minus. Now this guy is positive here, but again, because you have this negative here, you have to subtract the whole thing away. So this is really easy to make a mistake on. Go ahead and wrap this in parentheses so that you don't make a sign mistake because you have to subtract away 5x and then also 2. Then this equals 6. So here we'll have negative 4x and then plus 7. Again, just distributing the negative to each. And then I'm going to do the same thing here. So this is minus 5x and then minus 2. And this equals 6. Okay, so negative 4x minus 5x is negative 9x. And then 7 minus 2 is going to be 5. So plus 5. This equals 6. We'll subtract 5 away from each side. We'll say negative 9x is equal to 6 minus 5 is going to be 1. And then I'll divide both sides by negative 9. We'll say that this cancels. X is equal to negative 1/9. So let's put x is equal to negative 1/9. So is that in this interval? Well, negative 2 divided by 5 is negative 0.4, okay, as a decimal. And then this negative 1/9, that's negative 0.1 repeating, okay? So this value right here, this negative 1/9, is a larger value, or is to the right of this negative 2/5, and it's to the left of this 7/4, okay? So we can actually accept this solution. Okay, let's look at this last interval. In this case, we can just drop the absolute value bars in each case. So we'll have 4x minus 7, and then minus, again, when I drop this, make sure to wrap this in parentheses. I want to subtract the whole thing away. Then this equals 6. So here you'll have 4x minus 7, then again, minus 5x, and then minus 2, just distributing this to each, and this equals 6. Okay, so 4x minus 5x is going to be negative x, and then negative 7 minus 2 is going to be negative 9. This equals 6. So we're going to add 9 to both sides of the equation. This cancels. You get negative x is equal to 6 plus 9 is 15. Let's multiply both sides by -1. And that's going to give me that x is equal to -15. So let's put x is equal to -15. Now, obviously, this is not in this interval, so you can just reject this solution. So your valid solutions here, you would say that x is equal to -3, or x is equal to -1/9. Let's put that there. And again, you can pause the video and check each one of these solutions and verify that they work. And you can also check that x equals -15 does not work. All right, let's take a look at problem number 5 now. So we have the absolute value of x minus 2, then plus the absolute value of x minus 7, and this equals 5. So this problem is a bit tricky. So maybe you tried to solve it and you couldn't get it. So let's just go through it here. I'm going to start in our usual way. I'm going to think about x minus 2. Basically, where's that equal to 0? So let's set that equal to 0. We'll add 2 to both sides of the equation. We'll cancel that. So we'll say x is equal to 2. So we know at this point that basically if x was 2, then this would be 0, right? If x was something greater than 2, this would be positive. And if x was something that was less than 2, this would be negative. All right, let's slide this over here. Then we also have this x minus 7. Let's set that equal to 0, add 7 to both sides. We know this is x is equal to 7. Okay, so again, if x was 7, this is 0. If it's greater than 7, this is positive. And if it's less than 7, then this is negative. Let's put x is equal to 7 here. So let's go to the table and let's set up our intervals. So you're going to have one that's from -infinity going up to and excluding 2. And then I'm going to do this in 2 ways just to show you the difference. So here I'm going to go between 2 and 7. And with this one, I'm going to go including 2, but excluding 7. So a lot of people prefer to do it this way. I'll show you the difference between the two on this one, because what's going to happen is when you solve this, you're going to end up with 2 as a solution. And then here, you're going to get something weird. You're going to get an identity. So let's just keep going, and then I'll explain more as we go. Then over here, let's split this into 2. So we'll say this is anything greater than 7, and I'll also include 7 here for those that want to see it. Okay. Before I actually set anything up, I want to go up, and I want to advise you, if you're struggling with this problem, to take the left side of this and use an online graphing calculator like Desmos. It's completely free. I'm going to use MathGV. So you can just type this in, and you want to see where is that function's value equal to 5. In other words, where is the y value equal to 5? So go find where the function's value is 5 and look for the associated x values. So I have used MathGV to make a little graph for us. And so again, I'm looking for where the function's value is 5. So I'm coming across, and you'll see that it's right here through right here. And you can highlight the whole thing if you want. And basically that starts where there's an x value of 2 and continues through where there's an x value of 7. So graphically, I can see that the solution is x is greater than or equal to 2 and less than or equal to 7. So we know that from this graph. Now let's see if we can figure this out algebraically. Let's come back up here and let's grab this guy. So we have the absolute value of x minus 2 plus the absolute value of x minus 7. This equals 5. So in this first column, I know that everything is negative. So I would have the negative of this quantity x minus 2. So that's negative x and then plus 2. I just distributed the negative. Now here, whether you use this method or this method, basically you can just drop the absolute value bars. Here you could say that it's non-negative. Here you could say it's positive. Either way, it's just x minus 2. And then here it will be positive, so it's just x minus 2. Okay. With this x minus 7, it's going to be negative here and then also here, right? So I'm going to say that's negative x and then plus 7. Again, just distributing the negative to each guy. So then negative x plus 7. And then again, when I get here, whether I use this guy or this guy, it's either going to be non-negative with this case or positive with this case. Either way, just drop the absolute value bars. It's x minus 7. So whichever one you want to do. Okay. So coming down here, I'm going to solve the first case, and we're going to get something that's a bit weird. Okay. So the solution we're going to get is positive 2. Okay. So I'm going to come through here and say this is negative x plus 2. And then this is a plus sign here. So you can just go minus x plus 7, and this equals 5. Let's just solve this really quickly. Negative x minus x would be negative 2x. And then 2 plus 7 would be 9, and this equals 5. Let's subtract 9 away from each side. We'll cancel this. I'll just say this is negative 2x is equal to 5 minus 9 is going to be negative 4. Divide both sides by negative 2. This would cancel, and we're going to see that x is equal to positive 2. Okay. So does that work? Well, currently it doesn't, right? Because in this interval, again, I'm coming from negative infinity and I'm going up to and excluding positive 2. So I would say x equals 2, that's going to have to get rejected right here, okay? Now you might have some questions because again, when we go back to the graph, you can see that 2 is clearly included in the solution, and so is 7. So the way we're going to get that is basically when we think about this guy right here. So I'm going to solve this, and I'll come back up and I'll talk about this scenario and this scenario. Okay, so this is where if you're confused about including it or excluding it, this is where you can get some clarification. Okay, so for this one, we would just do x minus 2. And then again, because this is a plus sign, I can just go minus x and then plus 7, and this equals 5. So if you have x minus x, that's 0. Right, so that's going to basically cancel. So this is going to go away. So now I have negative 2 plus 7, which is 5. So you get 5 equals 5. So we saw equations like this earlier on in the course. They're called identities. They're always true for any value of x. But we have to only consider the values of x that are in our interval. If I get something like this, I'm just basically going to say that this tells me that its x is greater than 2 and less than 7. Okay, so here's where you have to make a decision. If you're using this method right here, which again includes 2, then at this point I can legally include 2, right? Because again, the setup is the same whether I think about it this way or this way, right? If this was 0, well then I could just drop the absolute value bars. If it's positive, again, I can also just drop the absolute value bars. So you can legally include that now. What I always do is just use this, and then I say, okay, does 2 work? I go back and plug it in. 2 minus 2 would be 0. So basically here you would have 2 minus 7, which is negative 5. And then the absolute value of negative 5 would be 5, right? This is 5 equals 5. That's a true statement. So that's how I would go about including 2. But again, if you want to do it this way, that's up to you. It's a little bit quicker. Now, on the other end, you see that 7 is excluded, right? It's excluded here and it's excluded here. But again, when we think about coming back to this graph, you'll see that 7 is included. So how are we going to get that part of the answer? Well, that's going to come in here. So let's come down and let's solve this part. So we have x minus 2, and then again, this is a plus, x minus 7, and this equals 5. So here, you're going to get x plus x, which is 2x. Negative 2 minus 7 is going to be negative 9, and this equals 5. So what we'll do here is add 9 to both sides of the equation. This will cancel. And we'll say this is 2x is equal to 5 plus 9 is 14. Let's divide both sides of the equation by 2. And we'll say that x is equal to 7. So coming back up here, I have x equals 7. Okay. Now, again, if you've included 7 here, then you're done. Basically, you can just combine these and say that x is greater than or equal to 2 and less than 7. And then you would say, or x is equal to 7. Now, this is easy to combine because you can just say that this is basically x is greater than or equal to 2 and less than or equal to 7, right? That's easy to combine. But let's say you did my method that I've been talking about. Well, here you're not done because technically 7 is not in there. So you'd have to take the extra step of plugging 7 in to verify that it's going to work, right? Just like I did with 2. So in this particular case, I would say that 7 minus 2 is 5. So you'd have the absolute value of 5. And then this right here, 7 minus 7 is 0, so that's gone. So the absolute value of 5 is equal to 5. You get 5 equals 5, so that works. So that's how I could verify that 7 is part of the solution. So again, just depending on the method you want to use. Okay, so let's go back up and let's write our solution. So we'll say x is greater than or equal to 2 and less than or equal to 7. And again, if you have doubts about this, you can, again, just go to the graph and see that that's the solution. You can also pick values that are in that interval. So between 2 and 7, including 2 and 7, we already saw 2 and 7 work, but you could just pick something like 3 or 3.5 or 3.25 or whatever you want, anything in that interval, plug it in and verify that you get a true statement. Let's just pick one real quick and then we'll conclude the problem. So let's just say we chose 3. So 3 minus 2 would be 1. So this is the absolute value of 1, which is 1. Then plus 3 minus 7 would be negative 4. The absolute value of negative 4 is 4. Does that equal 5? Yes, you get 5 equals 5. So this is a true statement. So this would be our solution. X is greater than or equal to 2 and less than or equal to 7. All right, let's take a look at problem 6 now. So here we have the absolute value of x minus 7, then minus the absolute value of x minus 3, and this equals 7. So in this particular case, I'm just going to tell you in advance, you're not going to get a solution. So I thought we would look at an example like this. So here we can kind of speed through this. We know that this one is just x is equal to 7, and for this one, it's just x is equal to 3. I think we don't have to waste time with that anymore. Let's come down here. Let's paste that here. So I'm going to have an interval from negative infinity up to and excluding 3. And then here it's going to be between 3 and 7. And again, if you want to include 3, you can include 3 there. It's not going to matter, but I'm just going to exclude it. And then you want anything that's greater than 7 right here. And then basically here, if you wanted to, you could include 7. But once again, I'm going to exclude it. Okay, let's look at our equation. I'm just going to copy this. So this is the absolute value of x minus 7, then minus the absolute value of x minus 3. This equals 7. And let's go through our cases. So in this first guy, this leftmost guy, they're both negative. So I want the negative of the quantity x minus 7. Let me just distribute this now. This is negative x plus 7. And then basically, I'm going to have that again right here. So this is negative x plus 7 again. And then in this guy right here, this is going to be positive. So I'm going to say this is x minus 7. Okay. For this next guy, you have x minus 3. So that's going to be negative here. So that's the negative of x and then plus 3. So I just distributed a negative to the x and then the negative 3 to get this. And then here it's going to be positive and here it's going to be positive. So it's just x minus 3. And again, if you're including things like the 3 and the 7, nothing is going to change here, okay? So it won't make any difference whatsoever. So let's go through and set up our first equation. So this is going to be negative x plus 7. You have to be really careful because of this minus. So minus the quantity negative x plus 3, and this equals 7. So let's solve this real quick. This is negative x plus your 7, and this is the negative of negative x, which is plus x, and then the negative of 3, which is negative 3. This equals 7. And then from here, you have negative x plus x. That's gone, basically, right? Those are going to cancel. So you have 7 minus 3, which is 4. So you get 4 equals 7, which is a false statement, right? So this is false. So there's no solution in that first one. You can come up here and just put no solution if you want, or you can just leave it blank. I'll just put no solution like that. Okay. For the next guy, we're trying to get between 3 and 7. So this is negative x plus 7, and then minus. Again, you have to be careful here. You're plugging in an x minus 3 where this is right here, but you have to wrap it in parentheses. You have to subtract the whole thing away. That's very important. So this would give me negative x and then plus 7, and then basically minus x and then plus 3, and this equals 7. So negative x minus x would be negative 2x, and then 7 plus 3 is 10, so plus 10, and this equals 7. So let's subtract 10 away from each side. Let's cancel this. You get negative 2x is equal to 7 minus 10 is going to be negative 3. Let's divide both sides by negative 2. This cancels, and you're going to get x is equal to 3 halves. So let's put x is equal to 3 halves. 3 halves, or 1.5, is to the left of 3 on the number line. So this is not going to work. This has to be rejected. Okay, so now we're down to the last guy, and we're just going to drop the absolute value bars in each case. So x minus 7, and then minus, again, make sure you use parentheses here, the quantity x minus 3, and this equals 7. I think you can see this is not going to work, because you can have x minus an x, so that is going to drop out, and this is not going to be 7 over here, so it's not going to be an identity, it's going to be a contradiction, right? So it's not going to work. But let's just go through it for completeness. This is x minus 7, and then minus x, and then plus 3. This equals 7. Again, this and this, that's going to cancel, right? X minus x is 0. Negative 7 plus 3, that's going to be negative 4. So you get negative 4 is equal to 7, which is false, right? So there's no solution there. So coming back, I'm just going to write that there's no solution, right? So this guy, this absolute value of x minus 7, then minus the absolute value of x minus 3, that's never going to be equal to 7. So coming back, I'm just going to put that there's no solution. And again, if you're a bit lost on this one or you have some doubts, you can always take this right here, this left-hand side, and you can graph it. You can type it into Desmos or any online calculator as it is. So the absolute value of x minus 7, then minus the absolute value of x minus 3. You could put f of x is equal to that if you wanted to. You could put y is equal to that if you wanted to. It's all going to produce the same graph. And you want to see where is the y value equal to 7. Pulling this up on MathGV, again, you're going to see that it's never going to be equal to 7. Okay, that's why there's no solution. If I had said something like, where is it 0? Well, this is a y value of 0. Just look for the corresponding x value. That's going to be 5, right? So if this had been, this guy is equal to 0 here, we would have found a solution of x equals 5, right? So this is one way you can clear up your doubts about things. You can just graph it and see what's going on. In this case, you see that that function that you create is never going to have a value of 7, no matter what x value you plug in. All right, let's take a look at problem number 7 now. So we have the absolute value of x minus 1, then plus the absolute value of x plus 2, then plus the absolute value of x plus 3, and this equals 5. So this one is a bit more tedious, but you use the same strategy. Okay, so it doesn't matter how many of these you have, you can just set up cases. Okay, I'm going to go through this a little bit more quickly. Now I'm going to tell you that one of these endpoints, specifically -3 is going to work. So that's another chance for us to look at what to do when that occurs. So for this one, you would basically say x minus 1, you set that equal to 0 and you solve. So you get x is equal to 1. For this one, x plus 2, if you set that equal to 0 and you solve, you get x is equal to -2. For this one, if you set x plus 3 equal to 0 and you solve, you get x is equal to -3. So let's grab these real quick. And I'm just going to paste this in. And let's just go ahead and say the furthest to the left is -3. So I want from -infinity up to and excluding -3. Now for this one, if you want to include -3, you can. It's going to make the problem a little bit easier. And this would be up to but excluding -2, okay? But I'm just going to exclude it for right now, and I'm going to show you how you could solve it this way. And again, maybe I'll put it down here just for reference, okay, in case you want to do it that way. A lot of people like this method better, okay? So then the other one would be, we would have between -2 and +1. And again, you can include -2 there and exclude 1 there. You're always including on the left and excluding on the right, but this one furthest to the left, everything has to be excluded, okay? I specifically want strictly less than -3, okay? Then this one right here would be anything that's greater than 1. And again, you could write this with 1 being included and out to +infinity. Okay, so let's get rid of this. Let's come up here and say this is the absolute value of x minus 1, and then plus the absolute value of x plus 2, and then plus the absolute value of x plus 3, and this equals 5. Let's do this one at a time. So first off, let's consider the absolute value of x minus 1. So basically, this is going to be 0 where x is 1. So I'm thinking about this column here, right? So if I include it, then at 1, it's 0, right? And anything larger is positive. So whether you're doing it this way or this way, you would just drop the absolute value bars in that case, right? So this is just x minus 1. Now, going to the left here of 1, well, it's always going to be negative, right? So I want the negative of the quantity x minus 1. And let's just do that now. That's -x plus 1. So this is -x plus 1. This is -x plus 1. This is -x plus 1. The other guy is the absolute value of x plus 2. So when x is -2, it's going to be 0. So again, if you had included it right there, that's where it would be 0. And then anything larger, it's going to be positive. So here it's going to be x plus 2. I could just drop the absolute value bars, either for this one or this one. And here it's going to be x plus 2, okay? And then going to the left, it's going to be the negative of this quantity x plus 2. So -x minus 2, and then -x minus 2. Okay. Lastly, we have this x plus 3. So that's going to be 0 where x is -3. So again, if you include it, that's where it's going to be. Or it's going to be positive if you're greater than -3. So again, either way, whether you include it or not, you could just drop the absolute value bars, and you get x plus 3 here, and you get x plus 3 here, and you get x plus 3 here. And then to the left of -3, which is where we are here, you would want the negative of this. So this is -x, and then -3. So let's go through and consider what's going to happen. We're going to see something interesting because -3 is going to be a solution when we get in here. And then also it's going to be a solution when we get in here. Okay, so let's come down here and let's think about the first scenario. So we're going to have all of these guys are negative. So -x plus 1. These are all plus signs. So just go through. We'll say plus -x minus 2, and then plus -x minus 3, and this equals 5. Let's just collect terms really quickly. -x minus x is -3x. And then 1 minus 2 is -1. And then -3 is -4. And this equals 5. Let's add 4 to both sides. We'll cancel this. And we'll say that -3x is equal to 9. Divide both sides by -3. And this is going to give me that x is equal to -3. Okay, this is canceling. Now, whenever you get something and it's on one of those breakpoints, well, you want to consider it. And at this point, because I use this method, I would make myself a little note to check -3. I would plug it in and see that it works, and I would accept it. But I would still reject it in my scratch work over here. Your teacher is generally not going to see this. This is where I'm going to reject because -3 is not in this interval, right? This is less than -3, so -3 is not specifically included. Now, when I solve this one, -3 is going to be the solution again, and here's where you have to make a decision, right? You can include -3 here legally because it does not change this guy right here. Whether it's -3 or something larger than -3, it's still going to be me just dropping the absolute value bars. So in this case, if you want to use this method, it's going to be a little bit quicker. But again, for myself, I would use this, and I would just test -3 and see, does it work? The answer is yes. So then I would include that in my solution set. So for this one, let's just go through it. So you have negative x plus 1, and then I'll just go minus x minus 2, and then plus x plus 3. This should be equal to 5. So negative x plus x, that's going to cancel. Let me just show that. This would cancel. And you have negative x. So 1 minus 2 is negative 1. And then negative 1 plus 3 is going to be plus 2. And this equals 5. Let's subtract 2 away from each side. We'll cancel this. We'll say that negative x is equal to 5 minus 2 is going to be 3. Multiply or divide both sides by negative 1. Doesn't matter. Let's just divide both sides by negative 1. This will cancel. And you're going to say that x is equal to negative 3. So if you're using this one right here, let me write this up here maybe. So x equals negative 3. If you're using this right here, well, negative 3 is included. So you can accept this solution. Now, if you're using my method here that I like to use, when I get something that's a solution that's a breakpoint, well, I just plug it in again and see, does it work? And I know negative 3 works. So when I write my final solution, I'm just going to include x equals negative 3. Okay, so that's how I do it. So for this one, let's go through and we'll say negative x plus 1, and then plus x plus 2, and then plus x plus 3 is equal to 5. So negative x plus x, that's going to cancel. So you have 1 plus 2, which is 3, plus 3, which is 6. So you have x plus 6 is equal to 5. If you subtract 6 away from each side, you get x is equal to negative 1. So x is equal to negative 1. Would I accept that? Let me write that up here. So x equals negative 1. Well, yeah, that's in this interval and this interval, no matter which one you used in this case. So I would accept that. So x equals negative 1. All right, let's take this one. We're going to end up rejecting. So you have x minus 1 plus x plus 2 plus x plus 3 is equal to 5. So x plus x plus x is 3x. Negative 1 plus 2 is 1. Then plus 3 is 4. So plus 4 is equal to 5. Let me make that better. If I subtract 4 away from each side, let's just say 3x is equal to 1. Divide both sides by 3. This cancels. You get x is equal to a third. Now, that is not going to be in that interval. Remember, this is anything that's 1 or greater if you're using this one, or this one is just anything greater than 1. Again, doesn't matter because here x is 1/3, right? And we have to reject that. So this would be rejected. So looking at everything, again, whether you use this method or this method, you're going to find that x is negative 3 or x is negative 1. So coming back, I'll say x is equal to negative 3, then or negative 1. And then again, if you want to do this graphically, you could take this left side here and punch it into Desmos or MathGV or whatever free calculator you want to use. And basically, the absolute value of x minus 1 plus the absolute value of x plus 2 plus the absolute value of x plus 3, just see where the function's value is 5. I see that it would be 5 just going across. Here, this is where it's negative 1, and then going across here, this is where it's negative 3. Okay, so you can verify that graphically if you have your doubts, but either way, the solution is x equals negative 3 or x equals negative 1. All right, let's take a look at problem number 8 now. So here we have 3x squared plus 16 times the absolute value of x is equal to 35. So I talked about in the lesson 2 different ways you could solve this type of problem. I'm just going to use a substitution. So first, I'm going to write this as 3 times the absolute value of x being squared, because remember, if I have x squared, that's going to be equal to the absolute value of x being squared. Those two would be equal. Then plus, we have 16 times the absolute value of x, and this equals 35. So now I'm going to let something like u or z or whatever you want to use be equal to this absolute value of x. So I'm just going to plug that in here and make a simple quadratic to solve. So this would be 3u squared plus 16u. And let's subtract 35 away from each side. So minus 35 is equal to 0. This is something we can solve using factoring. So I'm just going to put a 3u here and then put a u here. And let's set that equal to 0 there. For this guy right here, it's negative. So I know the signs are going to be different. And I'm going to subtract. I'm going to try to get the 16 in terms of absolute value. 35 is 1 times 35. And that's not going to work. And then you have 5 and 7. So that's basically it. So if you put the 7 here and the 5 here, you've got 21 minus 5, which is 16. Let's make this a plus and this a minus, and we'll be good to go. This would give us 21u, and this would give us negative 5u. And again, 21u minus 5u would be 16u. Okay, so we would say that 3u minus 5 is equal to 0, or u plus 7 is equal to 0. Let's add 5 to both sides, cancel this. We get 3u is equal to 5, divide both sides by 3. And we'll say that u is equal to 5/3. So let me put that up here. Put u is equal to 5/3. And then over here, I'm just going to subtract 7 away from each side of the equation. Let's cancel that, so it could also be negative 7. Let's put negative 7 there. When you solve these, you often get ones that you have to reject. So we let u be equal to the absolute value of x. So I'm just going to say that the absolute value of x is equal to 5/3, or the absolute value of x is equal to negative 7. And I'm just getting that by replacing this u with the absolute value of x. Okay, you can actually get rid of this. We don't need it. And you can even get rid of this if you want. You don't need it. Okay, let's bring this up here. Now, this guy on the right has no solution, right? The absolute value of x can never be negative 7. So we'll just put no solution for this part. And then over here, this is really simple. If the absolute value of x is set equal to 5/3, well then x is 5/3, or x is negative 5/3, right? And you can write this in a more condensed form by just saying that x is equal to plus or minus 5/3. So that would be your solution. You can pause the video and check each one and verify that they work. Okay, let's look at problem number 9. So again, we're going to use the same strategy here. Now you could clean this up first, or you could substitute first. It really doesn't matter. I think maybe we can clean up first. So let's just say negative 3x squared. I'm going to subtract 8 times the absolute value of x away from each side. So if I have 18 times the absolute value of x minus 8 times the absolute value of x, that's going to be 10 times the absolute value of x. Then basically if I subtract 2 away from each side, this is going to be 15 minus 2, which is 13. So plus 13, and this equals 0. Okay, so that's a simpler form. If you want to do the substitution first, you can do that and then simplify. Again, doesn't matter. So what I'm going to do is actually just replace this like this. Again, that's perfectly legal. And then I'm going to let u be equal to the absolute value of x. So this is negative 3u squared, then plus 10u, then plus 13 is equal to 0. And so with this one, I would actually multiply everything by negative 1. So I don't have to deal with that negative out in front. Let's change the sign of all those. And then 0 times negative 1 is still 0. Okay, so I'm going to factor this and put this as 3u, and then put this as u, put a 0 out here. And so again, this is a negative here, so I know I have mixed signs. And 13 is actually a prime number. So it can only be 1 times 13. So it can't be here because 3 times 13 is 39. It's just going to be too big. So it has to be a 13 here and then a 1 here. So let's see. This is going to be 13 minus 3, which is 10. So I need to make this negative and this positive so that I end up with 3u and then negative 13u. So positive 3u minus 13u would be negative 10u. So this is what I'm looking for. So what I'll do here is say 3u minus 13 is equal to 0, or u plus 1 is equal to 0. So this one we know that basically u is equal to negative 1, right? That one's easy. You can just subtract 1 away from each side. For this one, we would add 13 to both sides of the equation. This would cancel, and you get 3u is equal to 13. Divide both sides by 3. This cancels, so u could also be 13 over 3. Okay, so coming back up here, I'm actually just going to get rid of this. We don't really need it. So I'm going to say that we have the absolute value of x, because that's what u is. This is equal to negative 1, or the absolute value of x is equal to this 13 over 3. Okay. Once again, we know that the absolute value of x cannot be negative 1. This would be no solution. Okay, so no solution there. For this one, it's just that x is equal to 13 over 3 or negative 13 over 3. So we'll just say plus or minus 13 over 3. And you can get rid of all of this at this point and just report this as your answer. Again, you can check each one in the original equation and verify that they work. Okay, let's look at problem 10. So here we have negative 5 times the absolute value of x squared, then minus 8 times the absolute value of x, then plus 21 is equal to 8. Okay, so this one is really the same as the other ones. This part right here is meant to trip you up. A lot of books will do this, but you have to realize that the absolute value of x squared is the same thing as if I had x squared, right? These are both going to be non-negative. And it's also the same thing as if I had the absolute value of x being squared like this. In each case, you're going to get the same result, whether you have a negative, whether you have 0, or you have a positive, right? It doesn't matter what you plug in, those will always be equal. So what I can do is rewrite this legally and say this is negative 5 times the absolute value of x being squared like this, then minus 8 times the absolute value of x, then plus 21, and this equals 8. From here, again, I can just replace the absolute value of x with u. So let's say that we're going to let u be equal to the absolute value of x, and I'll say negative 5 times u squared minus 8 times u plus 21 is equal to 8. All right, for this one, let's subtract 8 away from each side. So this would be 0, and then 21 minus 8, that's going to be 13. And again, I don't want a negative leading coefficient if I'm trying to factor. So I'm going to multiply everything by -1. So that's positive. This is positive. That's negative, and that's still 0. So let me try to factor this. I'm pretty sure that we can. Otherwise, we can just use the quadratic formula. So this guy right here, again, with 13, it's 1 times 13 only. Okay, and this is minus, so I have mixed signs. Putting a 13 here is too big. So I'd have to put the 13 here and the 1 here. And so this is 5 and this is 13. So 13 minus 5 is 8. So I want to make sure that this is positive and this is negative, right? That way I get a negative 5u and a plus 13u. Let's make that 3 a little bit better. And so negative 5u plus 13u, that would be the 8u that I'm looking for. So we would say 5u plus 13 is equal to 0. Then or u minus 1 is equal to 0. So here let's subtract 13 away from each side. This cancels. You get 5u is equal to negative 13. Divide both sides by 5. And you get u is equal to negative 13 over 5. Now, do you need to include this? No, because u is the absolute value of x. And the absolute value of x is not going to be negative 13 over 5. So just get rid of this branch. You don't need it anymore. We're just going to consider that u minus 1 equals 0. And that's the solution of u equals 1. Okay, so let's get rid of all this. We're just going to come back up here and say that the absolute value of x, which was u, is equal to 1. So that means x is equal to 1 or negative 1. So you could go plus or minus 1 like this. So that's your solution. Again, you can always pause the video at this point and check and verify that 1 and negative 1 work.